Hello again. Here are the solutions to the Riemann sums exercises which were in the previous Riemann sums video and PowerPoint. So I'm going to click the solution there. That'll take me through to the solutions of number 1. First, of course, I have to find xi. There we have our bounds. There's the equation f of x. So a plus I into b minus a over n, so therefore 2 plus I into 4 minus 2 all over n, giving me 2 plus 2i over n. Now I need to find f of xi. So I'm now going to take that and substitute it into the equation. F of x equals 2x minus 2. There are twice that minus 2. That coming from there simplifies 2 plus 4 times I over n. So we can take our formula and we can substitute what we know. We know b minus a is 2 over n, and we know f of xi is 2 plus 4i over n. So next step, always separate the sigma notation. There we are. Next step after that, we're going to take out the 2, so we have just the 1, and we're going to take out the 4 over n, so that we have just the I. Now we can substitute that sigma notation with n, and that sigma notation with n squared over 2 plus n over 2. Simplifying, and because its limit as n tends to infinity, 4 plus 4 stays constants, and 4 over n becomes 0, goes to 0, so therefore that is equal to 8. So there is our area under that straight line. We click here to go back to the question. Note, remember, if you want to go back to the question, again, to remind yourself once you're busy with the next one, you come back to the question, and all you have to do is click solution, and you'll see it up to where you went. And then, so if you're halfway through this one and you click the solution, now I'm talking about the PowerPoint, this is now. You click solution, you work halfway, and then you need to know you can click back to this page, click the solution, see your full solution there to remind you, and then when you click here, you're back to halfway. Anyway, a bit more of a slightly more complex equation, x plus 3 over 2. What I'm going to end up doing is put half into x plus 3, just to save space, because, you know, you're pretty much handicapped in these PowerPoint screens to fit everything on. Now this one's a bit of a hubba because we have the 2, we have the x-axis, we have the line, but we don't have the value of that point there. So we're going to have to find the value of that point there. So that's my first step. That's an x-intercept. I'm going to take x plus 2 plus 3 over 2. I'm going to equate it to 0. There we are. And that minus 3, natty little minus 3, travels up to there. Now I have my left and right bounds as well. So we can now get going. First step always, xi equals. There we are. And I'm going to substitute minus 3 plus I into 2 minus negative 3 all over n, which gives me 2 plus 3. And there we have it, 5i over n minus 3. I'm just writing it the other way around because I find it clumsy writing with the negative first in a binomial. Now we need to know the fxi, so we're going to take this xi and substitute it into the f of x formula. Now this is where I use the half into, because of space problems. Now, when we take away the inside bracket, minus 3 plus 3, they eliminate one another. And so I only have half times 5i over n, so there we are. F of xi is 5i over 2n. So there's the formula. We know b minus a over n is 5 over n. And we're going to substitute that value there, f of xi, for f of xi there. That says f of x1. Sorry, it should be f of xi. So there it is. We don't need to separate the sigma notation, so I'm going straight on to isolating the I by taking 5 over 10, 5 over 2n. Let's say that again, 5 over 2n out, giving me 25 over 2n squared, and we'll have just I inside the sigma. Now we can substitute n squared over 2 plus n over 2 for this one, this sigma. Multiplying out. Now we're going to find the limit as n tends to infinity. That one there is a constant, so it stays. This one will tend to 0 with n in the denominator. So there we are. And there is our area bounded by the line, the x-axis, and those two bounds. Let's go back again. There we are. Now we have, oh, whoops, you see we have an above and below. So it says, don't forget about what happens to the area calculation when the graph crosses the axis. Let's go to the solution. The graph crosses the axis. Now, that is 2, that is -1, that's -3. So now what I'm going to have to do is calculate in two areas. So I have to calculate the below area first. It's going to end up being negative. Find xi. There's the formula. Substitute -3 minus 1 into the formula. And there we end up with 2i over n minus 3. Now we need to know f of xi in order to put into this equation. So I'm going to take the 2i over n minus 3 and I'm going to substitute it for x there. Here we are. And it simplifies to 2i over n minus 2. So there we are. Once again, that's f of xi. And I've substituted 2i over n minus 2 for f of x, because that's what f of xi is equal to. Next steps, separate the sigmas. And I've done a double step. Oh, how clever. I've separated the sigmas, plus I've taken the 2 over n out, giving 4n squared. This I've taken the 2 out, giving me 4 over n. Now we can substitute our sigma I and sigma 1 values from the formulae given on the formula sheet. And simplifying, we end up with that. 2 and -4 stay, they're constants. 2 over n tends to 0 as n tends to infinity. So we're going to end up with -2 as an answer. Now, because it's an area we're talking about, we're going to find the absolute value of that. So area 1 is absolute value of -2, which equals 2. So finished with that. So let's get rid of all that nonsense. Let's go there. And we're going to start finding the area in the second triangle there. It's from -1 to 2. So A is -1, B is 2. And we're going to apply our xi formula. -1 plus I into 2 minus -1. Giving us 3i over n minus 1. Now we can substitute this xi into the equation, giving us 3i over n. The -1 plus 1 cancels. Now a simple little one for us. Substitute back into the formula. So therefore we're now going to have that there. 3i over n instead of f of xi, that is. Now, first step, well, the first step we don't have to separate any sigmas, so I'm going to take 3 over n out, giving me 9 over n squared with an I. There we are. This we know from the formulae is n squared over 2 plus n over 2. Multiply it out. Constant stays. This one tends to 0 as n tends to infinity. So I end up with 9 over 2, 4.5. So we have now that the area 2 equals 4.5. And to find the full area, I'm going to add the 2 together. And that's the end of the solutions to those exercises.